Good morning. Welcome to this webinar about optimizing roaming for Wi-Fi devices. I hope that everybody can hear me. Okay, thank you for feedback. We're going to talk about what Wi-Fi roaming is and some other stuff, how to get it seamless, know that packets will drop, and what basic roaming will do. So what you can expect with basic roaming is to stay connected, but with real-time connections you may still experience drop video frames or sound drop-offs. So what do you need to do to get Wi-Fi roaming? For basic Wi-Fi roaming, it's pretty simple. You just need the same SSID, you need the same security settings, either no security setting, WPA, pre-shared key, enterprise, etc. And the SSID needs to be the same. And preferably, the SSID needs to connect to the same VLAN or same VPN. Which is desirable to achieve a more seamless roaming is good coverage without co-channel interference. Talking about the channel plan here, and you will want to have 802.11 KRV, fast roaming, etc. Which is not required, and this is a misconception with many people, is to have the same channel. You can have different channels, and it is also not required to be on the same band. You could, the access points or your connections can switch from 2.4 to 5 gigahertz or even 6 gigahertz in the future. So what can I do to improve and optimize my Wi-Fi roaming to make it more seamless, faster, with less packet drops? Well, start with improve your coverage, make a channel plan, select your channels and your channel bandwidth. And the other thing is to tweak your output power. And maybe setting minimum RSSIs on access points. So if you talk about channel plan, you can talk about 20 megahertz per channel plans, 40 megahertz channel plans, or 80 megahertz channel plans, at least in 5 gigahertz. And I have a small picture here that will show you that if you have channels 36, 40, 44, 48, then you are talking about a 5 or 20 megahertz plan. And with channels 38 or 46, you're talking about 40 megahertz, and with just channel 42, about 80 megahertz. So if you select 80 megahertz and at the same time you put one device on channel 36, if it allows that to you to do that, and another one of 40, and the next one of 44, and the other one of 48, basically they're all on the same channel. It may have a different number, but it's still the same 80 megahertz. So it will overlap, something that you do not want to. So if you have a 5 gigahertz, 20 megahertz plan, it could look something like this with all different channels. But you have to remember that except for the low channels 36 to 48, all those channels may change because of DFS. For 2.4 gigahertz, you can have something like a 3-channel plan, devices on channel 1, devices on channel 6, and devices on 11. Oh, I made it sort of a picture with balloons, and with the if you are trying to do the best coverage, usually you want to have the edges of your balloons to be at the -65 or -68 dBm ERP. I'm not totally sure where the number comes from, but that's at least what everybody advises you to have. You will still have coverage. The blue balloon will still have coverage into the brown and yellow balloons, but it will be less, and the coverage of the other one will be much stronger as the signal strength decreases with the distance from the access point. The same could be done with 5 gigahertz. In this case, I choose for 40 megahertz for channel plan. But again, remember that the channel 54 and 62 may hop to different channels because of DFS. Only the channels 38 and 46 are really fixed. So one of the things that we need to do or should do is tweak your ERP, because you have to remember that for this, at the same power, 2.4 gigahertz will have more range than the 5 gigahertz. So the 2.4 gigahertz balloon will be larger than the 5 gigahertz balloon, and you want to have them at the same size, so they have the same coverage and the same edges. So you know that also 5 gigahertz, again, because it's lower frequency than 6 gigahertz, will have a lower lower distance that they can achieve again. So for lower channels, they have more range. So you want to tweak the ERP to have them have the same range. How do you want to do this? Well, for 5 gigahertz, you want to have about 6 dB more power compared to the 2.4 gigahertz, at least for the low channels. If you go to the high channels, it might even be better to use a 6 dB more power. And for the 6 gigahertz in the future, something like 8 dB. If you want to plan this out, you could use something like our Easy Wi-Fi planner, which is accessible through our partner site. If you put in all the different access points in Wi-Fi planner, it will show you the power that is required to tweak your ERP. So then we come to the other thing where a lot of people have misconceptions about why and how does a Wi-Fi client roam. Basically, the Wi-Fi clients decide by themselves when to roam. This is part of the standard. They did not think at the start to put in a system that the access points would control when a Wi-Fi client would roam. Basically, everybody was just thinking about standalone access point and not even thinking about using multiple access points in any setup. So they didn't think of this, and well, it left us with this problem that the Wi-Fi clients decide by themselves, and at times it appears to be pretty random when they do and what they do. And that has some downsides. Wi-Fi clients may stick to an access point, even when there are APs available with the better signal, clearly get the better signal. And also, some older clients only roam. They really stick to the access point. They only roam at the moment that they really get disconnected. So when the access point is not in range any longer, and that's something that is well, then you have past 5 access points that have been better, but still you're on stuck on that one access point. Okay. So it depends on the implementation device. In some devices, they have set a minimum RSSI for roaming. So the minimum signal strength before it goes to hop, and it depends on brand, it depends on the make and model of the device, and in some cases even on the software version or firmware version of the device. In a very few devices, you can configure the minimum RSSI manually to make it roam faster. But I've not tweaked that myself. So in the past, we have seen some vendor-specific workarounds using a controller. Meru comes to mind with this. They have all the APs working on the same channel. You do not need a channel plan. The clients are not aware that there are even multiple access points. They just connect to the one. But all traffic goes to the controller, all the traffic. So if you go to the internet, it goes to your AP, then to the controller, and then to the internet. If you talk to another device on the network, it goes to the controller, and from the controller to the other device. The upside is that the controller receives with each packet the RSSI from each client, so it knows which AP is closest, and when it replies, it will choose that one AP. It worked well with the old standards, but now we have multi-gig access points, and you have, and if the controller needs to pass all that traffic, it will really need to be very beefy and maybe have 100 gig network connections even to manage a normal network. So I don't think it's really something that is very future-proof. At the same time, we also have had new standards to try to help devices find nearby APs more quickly so that they can roam a little bit faster. One of those is the 802.11k, which enables the client to ask the access point or the access point to list the access points that are near, so that the client already knows on which channel it can find other access points. When an AP determines that the client is moving away from it, the AP can inform the client to prepare, and the client then requests a list, and the AP gives the neighborhood report with a list of all the access points. And then at a certain point, again, when the RSSI is too low according to the client will move to the next AP. The downside is this needs to be supported by both client and APs, which is normal for most clients at the moment. So the report from the access point looks something like this. It sends a package. It says the action code that is a neighbor report response, and then it gives the number of channels. In this case, they are all 2.4 gigahertz channels, but can also be a 5 gigahertz channels like 36 or 40 that it provides. But that's only the part about knowing which channel you need to switch to. Then you still have the connection itself, and that will take some time. So the next thing they thought about was the 802.11r to make roaming faster and to reduce the time to re-authenticate. I will show something about that later. There are basically two methods: the over the distribution system, or that's over the local area network FT roaming, and over the air FT roaming. And the one over distribution, then if a device wants to go to another access points, it sends that to the first access points. The access points replies. It also sends a pre-authentication information to another client, and then the client switches and tries to reassociate and gets a response. So just 4 steps for the client. And the other way is over the air. It goes immediately to the other access point, and the access points share information over the local network. Again, there are 4 steps for the client to roam from the one device access point to the other access point. The local area network is used to share the opportunistic key caching or network pairwise master key to make this possible. To give you some idea about speed, if you have a normal WPA pre-shared key or enterprise, it goes something like this. And if you look at this display, you will see that it takes about 0.7 seconds just to get authenticated and associated. This is we still need to find the right channel, so there's a little bit of time extra there, but it just takes it already takes about 0.7 of a second just to get the device to connect. And you can understand that if you have to really basic roaming without any other things, that if the device switches from one access point to another access point, your phone calls and maybe even your streaming services will suffer when you switch. So this is not what you want. Then you go the fast roaming, and then suddenly you see that it only takes 0.03 of a second. So it's really much faster. Then again, do not forget that the device, the client, also needs to select, go from the one channel to the other channel. So it will take a little bit of extra time to do that too. But the difference between this and the difference between this is huge. So then we have, this is about the fast roaming. Then we will have the next step to make it even better. We have the 802.11v. This will make it possible for access points to just tell the clients, hey, I'm going to kick you. Of course, again, this needs to be supported by the clients and the access points. If one or both don't have it, it will not work. But if you have it, at least your access point can tell you, hey, I think you can better move to another AP. And that's not just because of the signal strength. It could also be that the AP decides that it's much more heavily loaded than another one, and the client will be better off on another access points that is much more lightly loaded than this one is. So there are 2 reasons. The RSSI is one, and the other reason is just the load on the access point itself. There are also some other stuff which also are included in the 11v, the directed multicast service, and the BSS maximum idle service. which is both for preserving battery life. So again, also with the 802.11v, we will see the neighbor port again with the BSSID channel number. And I think that in the past I saw there was a little bit more information than that, but I've been looking for nice captures about this, and I couldn't find any. So in this case, I'm a little bit lost with that how it was. So I'm not sure if it's identical to the information that you get with the 11K or a little bit more complete. So if you do not have V and the APs will not share that information, or the clients will not accept that information, we have one more thing that we can do, and that's setting the minimum RSSI on APs. You have to remember this is a brute force approach. This is very important to know. The upside, the overall throughput improves because devices will not be clinging to an access point even if the throughput becomes very low, because long before that the access point will have kicked it or tried to kick it. The downside is that well, actually two things. Because it's the brute force, of course, the client will lose a connection maybe when it doesn't expect it and need to reconnect. And maybe it can use the fast roaming, maybe it cannot. And if it cannot use the fast roaming, you will have a drop. Another downside is that clients at the edge of the outside edge of the network could get disconnected even though there is no stronger access point nearby, because the access point can only tell if the client is near that one access point. It doesn't know exactly where the client is and if it's nearest another access point or not. So if somebody is walking outside the building, the one that he's connected to can be the only one he can connect to, but it can get disconnected when you set this up like this. So it will disconnect any client from the access point when the connection becomes too low. But again, there's recovery here. If the client insists and just tries to reconnect to the access point again after being kicked, it will need to try a few times. But after that, it will be allowed to connect again. And then the access point will understand that it's at the edge and it's the only access point that can service the client. Still, you will have loss of packets during this happening. When you're setting your minimum RSSIs, again, for the same reason as setting the tweaking power, you have to remember that 5 gigahertz is a little bit less range. So you also have to tweak your power settings or the RSSI settings, and set the 5 gigahertz to a little bit lower than the 2.4 gigahertz to again have something that looks like the same coverage balloons, and that devices will be kicked at approximately the same places. What I found during preparing this was this site. And it lists a lot of different phones and other clients, and tells which channels it supports, number of MIMO streams, the Wi-Fi version it supports, including something like multi-user MIMO, so AC Wave 2, and if it supports 802.11v. It does not say if it supports the neighborhood reporting or fast roaming, but you can assume that if it supports V, it will also support the other two. So I have still some questions myself. I do not know if our APs send a disconnection imminent when a cable 802.11v capable client is at or below a configured minimum RSSI. So I'm not sure if setting the minimum RSSI will also do something with the 11v clients, or that it's totally separate. The other thing is that it's not totally clear to me how APs determine neighborhood reports. I'm not sure if they just know from the local area network, so not wireless but fixed network, if there which APs there are and are just reporting those, or, and this is something that I have seen, APs appear to do a background Wi-Fi channel scan, but at the same time that background channel scan, if the AP is checking out other channels, at that moment it will not be available for the normal service on its own channel. So that's a little bit of a downside for that. And in some cases we found that people were complaining that connections were dropping to clients and then reconnecting to the same access point, and this issue disappeared when the background scanning was disabled, either directly or due to by disabling some feature like 802.11v, which apparently needed to use the background scanning. And the other last thing is that I'm still wondering, again, I didn't have the traces that I was looking for. I'm still wondering if the A11v neighborhood report will contain RSSI values also for the client to get a little bit better idea which APs are closest by. So this is my presentation, and if anybody has questions, I noticed that somebody said about what's DFS. DFS is the system that 5 gigahertz need to use on the higher channels to avoid weather radar. So when it detects a weather radar, or it thinks it detects weather radar, it needs to vacate that channel and move to another channel. So where on the 2.4 gigahertz you can fix something to to any channel there. Say it needs to be channel 1 and it will stay channel 1 forever until you change it. In the case of 5 gigahertz, it's not that fixed. It's fixed for the channels 36, 40, 44, and 48, but all the other channels, they may need to change because of those rules to another channel. So it can be 64, and then it can be 100, and then at next time it can be 120 or something like that, and move around. So this makes the system of making a channel plan a little bit more intricate than for the 2.4 gigahertz. That said, any other questions? If nobody has any questions about this is going to be a very, very short presentation. So if anybody has any questions later, oh, I see that some questions are coming in, but anyway, if anybody has any questions later, or even suggestions about these theory talks or tech talks, just email to support@engeniusnetworks.eu. We will try to implement that. Okay, if your clients do not support the protocols, is it necessary to activate in the AP? No, it's not. But on the other hand, you can expect that clients over time will start to support it, and this will help your network in the future. So you really want to have this enabled. You can expect that over time, KR and probably K and R are pretty standard already in most clients, and 11V will become ubiquitous in the coming years. So all the clients all the 5 gigahertz and 6 gigahertz clients will start to support it. Okay, on quality of service. If you the whole idea of improving your roaming is to improve your quality of service. The thing is that I do not think that personally, that's my personal opinion, Wi-Fi will ever be, or at least for now, is not the perfect medium for something like phone calls, because of in general, Wi-Fi may have interruptions even when you're not moving between access points. But on the other hand, if you're using this and you have a mobile and you're using a VoIP client and you move from access point to access point, you can expect some drops even in the best of times. Well, there may be some situations that it's working perfectly, but you can have some troubles. At least people should expect that you may have the same effects as that you will have with normal mobile phones when you go into a tunnel and then get out of the tunnel. But when you're in the tunnel, that you can get disconnected. So that's something that you will have with Wi-Fi for now. And maybe in the future it will get better and better, but still using these rules like setting using the right clients, so preferably supporting KR and V, putting in a nice channel plan, setting your RSSIs on the your ERPs, the signal strengths for 2.4 and 5 gigahertz correctly will improve your the quality of the connections, and you should get a better result. About planning channel, what's about the DFS channels? You have to. I'm still struggling a little bit with that. I know that some vendors have something that they call dynamic channel selection, DCS, which is totally different from DFS. And the DCS, the dynamic channel selection, is something where when the devices need to move to another DFS channel, it will also check if the coverage and the channels are still okay. So if one device needs to move because it detected a channel on detected a weather radar or something like that, and it needed to move, then it will check, the other access points will check if there are conflicts and maybe start moving around a little bit. That said, this made the wireless network pretty unstable. So again, with some vendors, you see that these this reset or reconfiguration of the channels will only happen at certain time intervals, say like in the middle of the night once, so that during the day it will one device may move, or one access point may move, but the other ones will stay fixed until the time interval, and then the other ones will change. So in general, I would suggest that you try to use the lower channels as much as possible, and maybe work with a 3-channel plan with of 40 megahertz, one on channel 38, one on channel 40. Sorry, not 40. On the higher channel 46. So 40 and 46 or something like that, and the other one put only one on DFS so that he can move around without colliding with any other DFS channel. Mesh is not the same as roaming. There are large differences between mesh and roaming. Mesh is something that you need to connect multiple access points together, and in that case you will often have a situation that all the access points will need to be on the same channel, at least for one band, and then still if a client moves from one access point to another, even if it's on the same channel, they will need to do the same association as they have. So you will have the same situation, the same good things, the same benefits for using a KRNV. That said, in mesh situations, preferably you want to mesh on a different radio from the radio that is also used for an access point, and in that case you will not even notice that there's any meshing going on. I will prepare the presentation download later. I had some very recent changes to it, and I will upload it and prepare it. I get a question about, is background scanning not a good enough option to use to determine different channels? Well, the reason that we sometimes ask to disable it is because when you do backend, you have to understand that a radio can only work on on a single channel. If you move if you change to another radio channel, so you change from channel 1 to channel 5, then it will only hear the other channel. If the access point itself is operating on channel 1, but is going to do a background channel check on channel 5, at that moment it will not hear anything on channel 1, and it depends a little bit on how fast it gets back, how much time it takes to do the background scanning on all the other channels, that you will notice it not being there. And what we found is that there are some devices that are very sensitive to the access point not reacting for even a very little while. And if we find some environment with that, then we will, or that we suspect that something like that is happening, we will ask to disable the background scanning. I hope that answers Renee's question. And well, for those, yeah, let me see. I think that I have answered all the questions. Like I said before, if you have any questions later, just send them to support@engenius.eu. If it's in English or Dutch or even Spanish, it's okay with me. I will be able to read it. And even in other languages, I still have Google Translate. So okay. Let me see if I have. I think I have a few more questions. To get back to the background scanning, I think you want to have it enabled when it doesn't impact your network. But if it does impact your network, for what I understand, 11v requires background scanning. Without background scanning, it will not be able to provide a list of nearby access points. So that is why you want the background scanning enabled. However, when it impacts the devices, then yeah, it's the one or the other. So either you look for devices that are not impacted, or you disable background scanning. And in this case, background scanning would be the easy way to work around the issue. In a mix of 2.4 and 5 gigahertz in well, like I said, I would suggest you to set the ERP of the devices to such a level that they will cover the same area. And that's, I think, the most important tip that I can give in mixed environments. About the which channels to use, you can just use the 2.4 and 5 gigahertz channels totally independent from another. So it's not like that if you use channel 1 on 2.4 that you need to use the channel 36 on 5 gigahertz. These two things you can do totally independent from each other. And I think that's it. I see that one person expect, or a few persons expect that we continue this privately. That's okay with me. I will contact you. That's it, everybody. Thank you very much. Muchas gracias. Bedankt. And again, any questions or suggestions, just send them to us.